Finding an inverse function. You should recall that if we can say that f of x equals y, then f inverse of y equals x. This means that the inputs and outputs between a function and its inverse switch places. The function f of x equals 2x minus 6 is 1-to-1. We can find the inverse of this function by replacing f of x with y for simplicity, then switching the x and the y. This act of switching the input and the output turned the new y into f inverse of x. Solving for y will show us what this inverse function is. When I do this, I get that y, or f inverse of x, is x plus 6 all over 2, or x over 6 plus 3. This process is not always so simple, and can be much more fun. The function h of t equals 4t over 3t minus 8 is 1-to-1. I'll switch the t and y to create an inverse. Now solving for y has become immediately more complicated. There's more than one y. Let's remain calm and do what we might normally do when solving an equation. The denominator is certainly something I don't want, so we multiply by it on both sides. I still have two y's, and there are parentheses, also an ugliness. To get rid of these, I need to distribute t. I know that having the y's be on opposite sides of the equal sign doesn't help anyone, so let's move all the y terms to one side and everything else to the other. Now that I've gathered all of my y's, I can factor it out and see what happens. I now only have one y, divide both sides by what's in parentheses, and I have that g inverse of t equals 8t over 3t minus 4. You can now find the inverse of 1-to-1 functions. You can translate this skill to find an inverse function for the 1-to-1 portion of a non-1-to-1 function.